Gentlemen Falcons, and welcome to another edition of Math is More Than Fun at Pepin. I'm your host, Mr. Newber, and I'm going to review what we did on Wednesday with whole numbers, with mixed numbers and improper fractions. And if you remember, the first thing we did, we started out and we did a few definitions, and we agreed on a couple of things. The first thing is that what is a proper fraction? Well, a proper fraction, it's called proper because you know that in one of my other videos, I defined a fraction as a fracture. You cannot break something like a dinner plate, like a pizza. You open a pizza and people start gobbling the pizza. You're not going to end up with more pizza than you started with. You break a platter on the floor, you're not going to end up with a platter and a half. So everything involved with a proper a fraction is proper because you have less than what you started with. So here are some proper fractions, and I think you can see, in fact, let me make this a little bit different. I think you can see what we're looking at here is that the numerator will be less than the denominator. This is all pretty basic, right? But I want you to understand what an improper fraction is. So we may have perhaps 2 over 6. We may even have, how about a wild one? How about 17 over 23? Those are two prime numbers. You can have a big, ugly fraction like this. Doesn't matter. All we're doing is defining proper. If that numerator is less than that denominator, and you know it is, that's a proper fraction. That's all we care about right now, okay? So if a fraction can be proper or it can be improper, what's that all about? Well, we're just turning it upside down. And improper is the opposite of proper. So we're going to put down here improper. And improper means that the numerator is larger than the denominator. So let's put a 7 here and a 3 here. That's a pretty small number. And how about another one over here? We'll put an 11 here. Let's make some improper fractions here. Oh, I know how this works. I draw the fraction line and I put in a number that is smaller than that one. Ronnie Millsap can see how to do that. How about a 4? 7 over 4 is an improper fraction. 3 over, did you notice I only have 2 choices for this one? Think about that. I'm listening. I don't hear anybody saying anything. There's only 2 numbers I can put here and get an improper fraction. I'm going to put one of them. 3 over 2. And now 11, I just need a smaller number. How about a 7? That's a great prime number. There we go. Proper numbers, improper fractions. When we are talking about mixed numbers and improper fractions being the same thing, it involves both of these. Both of these. A mixed number. Now, let's define mixed again. You remember we talked about 2 things you can mix up. If you ever want to really mess up somebody in their garage, you can go in and mix together all of their screws and all of their nails. All right? All the nails you hammer, all the screws that you turn, and you take this pot of screws and this pot of nails, you mix them all together, just as a really bad joke. Don't do that. But the point I'm trying to make is mix has to be 2 different things. Can't be the same thing. You can't take a box of nails here and a box of nails here and put them in the same container. You didn't really mix them, you just dumped them in the same thing. Mix is 2 different things. And a mixed number has a whole number, everybody knows what that is, and now it's also aligned with a proper fraction. So if you remember, we did this, and in fact I'll do the same one because I remember it. It is 3 over 4. Now everybody knows that is a proper fraction. Why? That's right, because the numerator is smaller than the denominator. Well, that's part of a proper or of a mixed number. So all I need is a whole number. Let's pick one out. 3. So we have 3 and this 3/4. There is a mixed number. We just made one up. That's mine. You can make one up if you want to. But here's the catch. I put this plus here because back when the mathematicians were all very old men and they rode donkeys around trying to pick up some ink, all they had was feathers and ink to do their math on. They used to write it this way, 3 plus 3/4, because that's what it is. It's 3. You have 3 whole of something. Say that's a dozen donuts. So you have 3 boxes with a dozen donuts in each one, but the 4th box only has 3/4 of a dozen. Okay? That's what this is. You actually are adding those together, but the old mathematicians, why are we wasting ink on that? Let's do some math shorthand and just get rid of that plus sign. So now the proper form of a mixed number is the whole number and the proper fraction. So what I was trying to teach you on Wednesday is that this mixed number, if you have to add and subtract numbers like this, it's much easier to first convert them into improper fractions. Remember down here, the one we had here, where the numerator is larger than the denominator. So how do we get there? Let's take this one. This will be a good one. Let's take this and come down here, and we are going to have, yay, a pizza party. Here's a box. Here's a box of pizza, and it's sitting on top of another box of pizza, and it's sitting on top of another box of pizza. Now, I'm going to ask you, and then what we're going to do here is I'm going to go get the pizza for you, and I'm coming right back. So you come in the room for the pizza party. There's 3 boxes sitting here, and there's a box sitting here, and the lid is open. What are we going to see inside that lid? What are we going to see? Well, why are there 4 slices here? Anybody? Somebody said it. Somebody said, because there's a 4 in the denominator up here. This is the one that goes with the proper fraction, because this is a fractional amount. Forget the boxes over here. This is a fractional amount. So here is the pepperoni. And now everybody in the room, except Mrs. D, hopefully, realizes Mr. Newbert ate a slice of that on the way over to the party. Okay? There's only 3/4 of a pizza. There is a missing slice of it, a good sized slice too. It's missing. How do you know that? Well, we opened the top and we looked at it. So we're going to write that down. That's 3/4. That's 3/4 of a pizza. So let me ask you this. This is a trick question. How many pizzas are there? Well, there's one here. There's a box of pizza there. There's another one here. There's another one here. But remember, there's also one here. So I walked in the room with 4 boxes, but I revealed this one to only have a proper fraction because I ate a slice. So now if there's 4, remember, math class, especially pizza, is perfect in math class. That means every single one of these pizza, if there was 30 boxes here, every single one of them is exactly to the crumb, exactly the same size, and every one of them is cut for 4 slices, or the math doesn't work. Every one of them is cut in 4 slices, and every one of those slices are exactly, precisely the same. Okay? So, who can tell me how many slices are in that pizza right there? Go ahead, I'll wait. Tommy Turtle just told me, get quiet. There's 4. There has to be 4 because it's identical to this one. This one had 4 till I ate a slice on the way over. How many's in the second pizza? 4. How many's in the third pizza? 4. Okay, you see how we made this? What's this 3 signify? These 3 whole pizzas that we haven't even touched it. In fact, I set them down, nobody's even touched them yet. But I set this one down and opened it up, and there's only 3/4. So our mixed number is going to have this 3 right here and this 3/4 right here. That's where this comes in, because I think every one of you would tell me that if I asked you and it was an actual pizza party, you would tell me this is 3 and 3/4. Well, this is 3 and 3/4. Okay? Does everybody get that? Is that a good one? We could do this with pizza all day, and we probably will if we need. We need to make sure we understand where this comes from. Now, if I wanted you, this is fine. This is good. 3 3/4 mixed numbers are beautiful. You're just going to love working with them. However, if we're going to add and subtract fractions, if we're going to add and subtract mixed numbers, it's much easier to turn that mixed number into an improper fraction. And why is that? Well, let me give you a quick example. Here is 11 over 6, and if we're going to add or subtract, say, 5 over 6, all we do here is do the numerators. 11 plus 5 is 16 over 6, or if we were going to subtract it, 11 minus 5 is 6 over 6. Easy. You're just subtracting two numbers. Pepin Falcons. This math video is being interrupted because somehow I lost the 3 minutes of this video that I was in. I was just outside talking to some adults in the neighborhood, and I realized my download stopped when I was putting it on YouTube, so I need to finish the video right now, okay? So let's go to where I was in the video. I already checked this out, and we were talking about 3 boxes of pizza, actually 4 boxes of pizza, but 3 of them unopened. There's 4 slices in each one, and we know that because of the denominator. And this was the one that was open. This was the one that was on top in the seat beside me when I drove it to the pizza party. And okay, that's the piece that I had. So this is 3 out of 4. Out of 4 slices, that's 3/4. This is the definition of a mixed number. It's a whole number. There's 3 whole pizzas over here, plus a proper fraction. And that's what we have. And I told you about math shorthand, and I will tell you some really good stories about that because generally in the old days it involved the older guys who were teaching math. All right, let's go to this now. Why are improper fractions easier to add and subtract than mixed numbers? There's one simple answer, and that is there's only one simple move. When you have an improper fraction, 2 improper fractions, 1, 2, you have 2 improper fractions. When you're adding and subtracting, you're only doing 2 numbers. These are fractions. We're adding or we're subtracting, and we have identical denominators. Okay? So all we have to do is add the numerators. There and there, or subtract the numerators, or add this numerator, or subtract this numerator. That's all we have to do. With mixed numbers, adding 2 mixed numbers together, it's a little more complicated, and I want you to have the best way to do this operation, adding numbers like this. So here, all we have to do is add 7 and 2, and we get 9. The answer is 9 over 3. 12 minus 4 is 8. 8 over 5. 20 plus 5 is 25 over 6. See what the answer would be? 25 over 6. Okay? Down here, 8 plus 7 is 15. That's 15 over 4. And this one is 10 minus 5. 10 minus 5 is 5. That's the numerator. You keep the denominator, and that's why now this is the critical information I had to get in this video. Now I can relax, go back to my adult friends that are outside waiting for me, because now you know why it is much more efficient to add and subtract improper fractions than it is mixed numbers. Okay? All right. I will see you on the next video. Watch for Coach Giovinco.